So one of the most popularly requested problems is homework 6, exercise 9. And here's what we're doing. We're trying to do something with a 1 over n chance of success. And basically what we're going to end up doing is we're going to be looking and seeing if you have a 1 over n chance of success, how likely is it that you need n or fewer chances to succeed, or alternately, that you need more than n tries if you have a 1 over n chance of success. So x sub n is going to correspond to this 1 over n, and it's going to be that random variable that gives us the number of trials before and including our first success. So if we want to, we can say that xn is distributed like a geometric with parameter 1 over n. Okay, so our first question A is, what is P of x10 being less than equal to 10? So fewer than 10 tries, each try we have a 1 in 10 chance. And here's how we're going to think about it. We're going to say, there's multiple ways that we could do this, but the way that we're going to say it is we're going to say, okay, this is going to be 1 minus the probability that x sub 10 is greater than 10. All right, and in order for x sub 10 to be greater than 10, we need to get a failure on the first try, the second try, the third try, all the way up to the 10th try. And so we can say what this is. What's our probability of failure? Well, it's going to be 9/10. And we need to do that 10 times in a row. Okay, so that's for part A. We're going to just plug this into R at the end. Okay, but this is sort of in LaTeX our answer. So that's for A. For B, we're going to do the same thing, except for now we have x to the n being less than or equal to n, and we're going to rewrite this as the probability of xn being greater than n. And similarly, this is 1 minus, okay, instead of 9/10 here, we have like n minus 1 over n, but I'm going to write this as 1 minus 1 over n. And that's all going to be to the power of n. All right. And how are we going to approximate an R? We want to know the limit as n goes to infinity of this, of 1 minus 1 over n to the n. And this is going to be approximately, well, let's just do it with a big number in there. 1 minus 1 over 999 to the power of 999, something like this. Okay, so this is how we're going to approximate it in R, is we're just going to plug in a big number here. Okay, and then part C uses the identity that I have in mind, which is sort of, it's important at some level that you get it into this form here. Like if we had written this as n minus 1 over n, this identity would be less obvious. But the identity is that e to the x, or maybe we'll write it the other way around, the limit as n goes to infinity of 1 plus x over n to the n is going to be equal to e to the x. This is the first definition I ever learned of e to the x. I was learning about compound interest in middle school, and I learned this. And what you can see here is that if we set x to be minus 1, then we have the limit as n goes to infinity of 1 minus 1 over n to the n is going to be equal to 1 minus e to the minus 1. Okay, and if we do a decimal approximation of that, we get that this is about 0.6321. Okay, so the probability that we'll have a success within n tries, if we have probability of success being 1 over n, is about 63.2%. Okay, so now we're gonna jump into R and do this in R. Okay, so in R, now given what we have, this is actually a pretty straightforward thing to do. So the first thing that we want to do is 1 minus 0.9 to the power of 10. And that's going to give us about 65%. We should see this number come down as the next one. How are we going to approximate this? It's going to be 1 minus, say, 1 over 999, I think was the example that I gave, to the power of 999. Similar vibe here, a little bit smaller. And then if we do the limiting one, it's going to be 1 minus the exponential of minus 1. So this is the limiting value here. Right, you can see that 999 is a pretty good approximation to this limit.